Okay, let's do an example in which we turn a normal random variable to standard normal and use the z table for z to find its probabilities. Here we have a normal random variable x with mean 25 and sigma 5. The question asks for probability of x being uh, bigger than 26.35 and probability of x being less than 19.5. Also ask for value of a for which x probability of x being less than a is equal to 0.9641. Okay, so as we know, the key point is that for any normal random variable, x minus mu over sigma, whatever mu and sigma is a standard normal random variable, and here we have x minus 25 over 5. Wherever you see x minus 25 over 5 in this question, you just replace it by z. Okay, so that means that I can start working on probability of x bigger than 26.35 by turning this to x minus 25 over 5. So let me subtract first 25, probability of x minus 25, but I have to subtract the other side also 25, okay, and then divide both sides by 5. This is probability of x minus 25 divided by 5 bigger than, well, 26.35 minus 25 is 1.35 over 5. Now you see that x minus 25 over 5, as we had before, this is probability of z, and this is going to be bigger than 1.35 over 5 is 0.27. Well, there's no x now, it's just standard normal random variable, and we have table for that, and we know that to be able to use the table we have to turn this z less than something, so it will be probability of z less than 0.27. 1 minus that will be what we are looking for. But to find the value of probability of z less than 0.27, I need the table for z value. And here I am 0.2, so this is 0.2, and then 7 is somewhere there, yes, yeah, and that's the number we are looking for, 0. So 1 minus 0.6064, and well, this is a subtraction, basically this is 6, 3, and then 9, this is 3. 0.3936 is probability of x being bigger than 26.35. Okay, how about the other one, probability of x being less than 19.05, okay, minus 25, that's what we do, x minus 25 less than 19.05 minus 25, and then divided by 5. This is probability of x minus 25 over 5 less than, okay, so 19.05 minus 25 is 5, negative 5.95, and then divided by 5. Okay, x minus 25 over 5 is Z, standard normal random variable, and this guy, negative 5.95 over 5 is negative 1.90. And then, well, okay, very nice. We can now try to use the table to find this, but this is z less than a negative number. So we have to first drop the negative sign. But when you drop the negative sign, you have to flip the inequality. Now this is z bigger than a positive number. You can turn it to z less than by subtracting it from 1. So it will be 1 point. So if I can find what is z less than 1.19, let me bring this a little bit closer here. We are done. So 1.1, this is 1.1, and go all the way down to the 0.09. That gives me the number 88, 1 minus 0.8830, and that is 0.71. There is another one, and that's 0.1170 is the probability of x being less than 19.05. Okay, that was part one. How about part two? Part two is a little bit different. Yes, this time we are looking for a such that probability of x less than a is 0.9641. Okay, I don't know what is a, but if I can turn this guy x to z, I can somehow use the table here. What happens is that I can do x minus 25 again, so a minus 25 over 5 over 5. I didn't change anything, so the probability will stay the same thing. This guy is probability of z less than a number here. I don't know what is that number at this stage, but I know that it's a number for which the probability of z less than that number is 0.9641. Let's just replace this guy by k. So we basically have probability of z less than k equals to 0.9641, and we know that k is a minus 25 over 5. So if I find k, I can find a. Okay, so here x z less than k is 9641. We have to find 9641. 9641, it is here. So if this number and this number, so then that means that k is equal to 1.8 then 0. But we know that this is also k is also equal to a minus 25 over 5. Well, that's what we want. Now we have a minus 25 over 5 is equal to 1.8, and I can multiply both sides by 5, get 5 times 1.8, which is what? This is 9. Absolutely, yes. And then a equals to 25 plus 9, which is 34. The number a we were looking for was related to this k that we found it from the table, and then find a, and that a is what we were looking